This video is to help you review learning targets A through F. There are some problems here that I posted a blank lesson for. I'd like you to do all of the problems before you watch this video and then use the video to check your work and for explanations to the work. So pause the video right now and go through and try the problems. Then you'll be prepared for the quiz. So, when we look at a set of ordered pairs, and that can be in the form of a t-table or a list, we can determine whether it's a function or not as long as none of the x's repeat. So if you look at question number 1, we have -2 and -2. The x's is repeating, so this is not a function. So remember, if it's a function, each x value has only one exact y value answer. And if I say, when x is -2, y is, you would tell me -4, oh, but then also +4, and you can't have two different y values assigned to an x value. So this is not a function. It is a discrete function because it's individual points. It's not a graph where you have points that are all connected. The domain is the set of all x values. So the x values that I have are all of these right here. But you only need to list them once. And we usually go in order from the smallest number to the largest number. So this would be your domain. Your range is the set of all y values. And so my y values are these right here. And again, I only need to list them once, starting with the smallest one. Sometimes they might be in order, like in this case, but not always. Okay, the second one. If we take a look at whether this is a function or not, we can see, first of all, look for repeated x's. All of these x's are different, so it is a function. For every x value, when I would say when x is 2, y is, you'd only have one exact answer. This again is discrete because it's separate individual points. The domain, remember our x's are all of the x values in your function or relation. So 1, 2, 3, 4, 5, 6. Whenever you have a discrete function, your domain and range will always be separate individual numbers compared to a continuous function where you'll have an inequality. So my y values are right here, and again I'm just going to list them, and these happen to be in order as well. So 3, 6, 9, 12, 15, 18. Whoop. So there we go. Moving on. Okay, so now we're looking at graphs. Is this a function, yes or no? Well, for when I say when x is 1 right here, y is, you have two different answers. This does not pass the vertical line test, so it is not a function. It is a continuous function because you not only have these points that you can see here, you have these points that they have sort of on your graph, but you also have an infinite number of points in between. Too many to count. And in between the points I just put on, there's more points. So that's why it's continuous. Whenever you have a line or a curve that's connected, that will be continuous. The domain is the x values. Okay, well here, your x values, you have x as -1. You have an x value at 0. And you have some at 1 and 2 and 3. So my graph never goes beyond -1 or 3 on my x-axis. So that means my x values are less than or equal to 3, but they're greater than or equal to -1. And that's how we list that. And we can use that set notation again if you want, but it's not critical. Now your y values, let's take a look at those. Your y values never go above 2, and they never go below -2. So again, your y values are less than or equal to 2, but they're greater than or equal to -2. So that's how you write those inequalities. Let's move on to number 4. Is this a function or not? Well, again, it passes the vertical line test. So yes, it is a function. Again, you have an infinite number of points on your graph, and they're all connected together, so that's why it's a continuous line or curve. So it is continuous. My domain, again, is my x values. So look, here's your x-axis, okay? Your x-axis is sort of like your number line, and your values never go beyond -2. But if you notice this arrow here, right there, that means they keep going infinitely in that direction. So that means my x values are greater than or equal to -2. And there, I guess you could also say that they are less than or equal to infinity, okay? And some people will use that, but again, that's not something we have to do. We can just leave that part out, but that's what's really happening. And then your y values, well, my y values right here never go below this point. And again, this arrow shows that they're going to infinity on the y-axis as well. So that means my y values are greater than or equal to, looks like 1, 2, 3. So greater than or equal to 3. All right, let's talk about independent and dependent variables. You're participating in a walkathon for a good cause. If you were to graph the relationship between the money raised and the distance you walked, what would be the independent and dependent variable? Well, which depends on which? Well, the money you raise is going to depend on the distance you walk. So your money depends on your money that you raised depends on how many miles you walk or distance you walk. Clean this up a little bit. The distance you have walked. The further you walk, the more money you raise. So money depends on. So money is your dependent variable. So your money raised is your dependent variable, and the distance walked is your independent variable. So is this going to be discrete or continuous? Well, it could really be both, but if you think about when you walk, okay, you walk 0 miles, you walk 1 mile, you walk 2 miles, but you have to walk all of those distances in between. And smaller increments. We can't count all the teeny tiny pieces of the mile. So this would be continuous because it's not countable. It's something we would have to measure. So we say it's measurable. And then this is just a quick little review of function notation. Remember this, when we have this notation, f of -3, that means we're taking our x and replacing it with -3. So f of -3 would be 2 times -3 squared plus 3. That's 18. -3 times -3 is positive 9 times 2 is 18. Plus 3 more is 21. And again, looking at independent and dependent variables, we had an example above, but if Suzanne earns $7 an hour walking her neighbor's dog, okay, how much money would she earn? Well, we might start by writing the equation y equals $7 times the number of hours she walks the dog. But in function notation, we take that y and replace it with f of x. So f of x equals 7x would be our equation. And then evaluate it when she works for 5 hours. That's f of 5. So that equals 7 times 5, which is 35. So she would earn $35. So you will be taking a quiz, okay, on chapter 4. If you're in class, you will be working with a partner to do a practice quiz, but then everyone will be doing the Learning Target A through D quiz that's in Schoology. All right, that's our review.